Good morning, sir. Prof, sir.
Yes, good morning. Please start.
Allow me to share my screens,
Yeah,
please.
yeah, share your screen. Admin, please allow to share screen.
Awotunde, Joseph. Okay. Awotunde.
Ẹ tó kún slide ní tẹ́lẹ̀.
Mo ti open.
Ẹ tó kún náà.
Mo ti open. Ó yẹ kí ẹ ti rí báyìí.
Yes, it's perfect. Yeah, it's fine.
Yeah.
Good morning, sir.
Good morning, good morning.
Sorry for the delay. My time.
No issue, no issue. Please start. No issue. Please start.
Okay. I'm here to present a paper titled A Future Selection-Based KNN Model for Fast Software Defect Detection. And my name is Awotunde Joseph Amintele from University of Ilorin, Nigeria. These are the presentation outline, introduction. I will talk about the contribution to the study, methodology, result and discussion. Then I will conclude. The introduction, the software has been the art of
No, it's not.
technology.
Your slide is not moving.
I've shared it, sir.
But tí ẹ ṣe ẹgbẹ́ glossy presentation
Ibo ni presentation.
nísàlẹ̀. Okay, ẹ ti ṣe.
Mo ti ṣe. I've shared. Have you seen it now, sir?
Yeah, it's fine. It's fine.
Ẹgbẹ́ ọkẹ́ máa tọ̀lé bẹ́ẹ̀ sáré.
Ṣé ẹ ti rí?
Ẹ mo ti rí bẹ́ẹ̀.
Tí máa wá gbé sílé ẹ̀rí àbí?
Ẹgbẹ́ sí ẹ tó try ẹgbẹ́.
Mo ní mo ti ṣe try. Do you see it now?
Nínú kò sí.
Okay. The software have been the art of technological area where virtually all organizations are in need of one software or the other. The program package and some other things have been found in virtually any organization because they are moving from a manual way of doing their things to a smart way of doing it. So you will discover that almost all organizations are using software now. But if there are frequent software defects, the main aim of creating them will be defeated. So if the organization or industry that are using software often complain about the software product, you will see that the main aim of buying those software in such organization will be defeated, and the art of continue buying more software will not be there, and the credibility and the reliability of such software too will be in question. So as a result into software that certified the customer and thereby worsen the software company image. If faults are discovered at the beginning of software development process, resources can be allocated to only the software component that are required. What I'm trying to say there is that if the developer, the programmer can easily detect or detect software default at the beginning of when they are trying to develop or design a software, you will see that the resources will be reduced, especially during the debugs and some other things. So we said as software defect detection is one of the key features with the continual increase in software industry for manufacturing quality software. Then machine learning model has been gaining greater attention in recent times in prediction of software defection. This was done in order to give timely delivery of software products with maximum deployment of available resources. With the introduction of machine learning, deep learning, artificial intelligence in detect defection, software defection has been emerging in recent time, and it gives easy way of detecting defect within a software. Why? Because the essence of going into manual way of detecting bug and the defect will not be there again. And but the problem of imbalance and high dimensionality of software database has been hindered the performance of MLB model, and that's one of the problems. Which data is there, but imbalance and high in dimensionality or such soft data set using the software, it can either the machine learning based model. Then the accuracy has been identified as a good evaluation metric for comparison when considered the binary problem. But in a situation where the number of instances of more one class is used than other, the accuracy of such model
But
will
Moses,
not
so you can go in presentation mode, start in presentation mode, I think. Yeah.
be. The contribution of the key contribution, we are trying to use feature selection with extra boost, gradient boost classifier for software division. These are the contribution. The application of software feature selection to reduce the high dimensionality of the software defense dataset. The sampling method was applied to handle the imbalanced instance within the dataset. Here we use mode for the imbalanced instance. Then the last, after doing that, we are able to now use edge boost algorithm to be able to classify whether a software have a defect or not. These are the methodology. The methodology is classified into four basic types. The first one is pre-processing. In the pre-processing, we remove the duplicated inserts, we replace the misplaced label, and we do the data normalization. Then after we're able to do that, we move that to the feature selection. I've explained that the essence of using the feature selection is to be able to choose the best feature that will be able to allow us to classify the software defect accurately and give us a higher accuracy. Then what we use there is chi-square statistical algorithm. Then after that, we are able to divide our data set into training and testing. The training take the 70% and the testing take the 30%. Then after that, we are able to now use the edge boost classifier to be able to detect either there is defect or there is non-defect. Then after that, these are the performance metrics we use. We use accuracy, F-score, ROC, and MCCI. These are the performance evaluation that I just explained. These are the results and discussion we have. The table 3 so the four data sets we use. These are the NASA data set. We use four of them. They are up to it, but we just pick four of them to be able to use them to check the performance of this result. So the first one, we try to see these are the main feature that each of the data sets are. After we use the chi-square statistical model, the first one, PC4, have 17, PC5 we use 19, then JM1 we use 8, and the last one, which is KC1, we use 10. So these are the ratio in percentage of what we use. Then the second table, which is table 4, display the performance metrics we use, the accuracy, the F-score, and the MSC. The first one, we see that we have the highest of it is PC4, which is have 95% accuracy, followed by PC5, which is 93% accuracy. Then we have 89 for JM1, then F1 and this one. Then what this one is telling us is that we try to use the model and check before using the feature selection on the data set. Then after using this data set, this is what we get. You will see that the accuracy is greatly increased. For PC1, PC4, we have 99.5 accuracy. And we have PC5, we have 96. The least of them is CK1, which is 82.3%. And these are the F-score and MCC metrics that we use for the algorithm. We can see that the introduction of feature selection greatly improve the accuracy and F1 score of the software defection machine learning we use, which is FB boost. Then in conclusion, the proposed system uses chi-square. I've explained that for feature selection. Then we do a normal data normalization. And remember I said because of the number of pages you are unable to put that there, we use we try to balance the data set by using smooth too, so that we'll be able to have a balanced data set and normalization. Then after that, we now use the GS boost to predict the NASA data sets. Consider the performance of the model of the fourth data set. The GS weight feature selection perform better on the PC4 data sets, and the worst of all the data sets is KC1. Then we can conclude that using a machine learning based on the finding the default software default is very important, because it's going to give us an higher accuracy when we compare to the manual method we normally use. And the application of we are thinking in the future that introduce deep learning with feature selection can still improve the classification of software defection, module defect. Thank you for listening.
Okay, thank you, thank you. So tell me one thing. I mean, once you applied the feature selection, your
Yes,
result,
sir.
your results have been improved.
Yes, sir.
Without feature selections, your results were not so good.
Yeah, the
So
result
what?
is
Yeah.
the
So why,
the result
why it's
the
happening?
result is the result is good too,
Yeah,
but the future selection greatly increase. Even if you see the first one, which is PC4, we
yeah,
have
that's
almost
yeah,
4%
that's
increase.
that's that's perfectly fine. But
Yes.
what's the reason behind this?
Hello, sir.
What's the reason behind this? Why without feature selection, the performance of classifiers are not so good?
I think what really, before even applying feature selection, we are doing what we call, we have balanced the set using smooth. I think that one will contribute to, even before using the feature selection, that also will increase the performance of the machine learning. I think the issue of balance the data set to contribute to that before even apply the feature selection, sir.
No. Feature selection is not used for the balancing of data, but you are choosing some important features from the given set of features. So why the performance increases in case of you applied the feature selection? This is my question.
Yes, I think because the feature selection was able to select the best feature that
Yeah.
are very good for classifying the data set.
I mean, suppose when you are taking suppose 10 features, no,
Yes, sir.
and after applying feature selection algorithm, suppose you select only 4 features.
Yes, sir.
So once you are training your model on 10 features, even all the fours are included in that.
Yes, yes, sir.
Yeah. So are your problems first with the class overlapping problem? Are you ever with that class overlapping problem? Class overlapping.
I didn't understand that question.
You heard
Sorry.
about class overlapping problem?
I think what feature selection really do for us is to be able to select the best feature that we can use to classify whether the data set have default or not.
But you have used only chi-square method, no? Because there are several feature selection methods.
Yes, there are some other.
Have you compared with those features also? Selection?
No, that will be part of the features. My God, what I'm trying to do now is I want to try to use biosphere with statistical method to see which one that will perform better out of the two.
Okay. Any questions from other participants? Any comment? Any queries from Moses? Okay. Thank you. Thank you.
Thank you, sir.
All the best.
Professor Singh, can I ask?
Yeah, please, sir. Please.
No, you first. I need the permission from chair, right? Yes, Joseph, can you tell me that this is a software quality conference, and how are you correlating your work with the quality aspect of the software?
Sir, I didn't hear you well, sir.
I'm saying that this is a means where you are presenting. It is International Symposium of Software Quality.
Yes,
How do
sir.
you correlate your work with the quality?
Ah,
With the software quality topics.
Yes, sir. I've said it that the software can be found in different companies now, but you will discover that if a software is not work to the specification of the claims, there should be a problem. So one of the way to increase the quality of a software product is to be able to detect any defect before taking it to even to the organization or the clients that want to buy the software. So it's going to increase the software quality. Why? Because you'll be able, it will help the programmer or developer to be able to detect any default or bugs that can create bottleneck or problem when it gets to the level of implementation. So I think the detect defect before the production of the entire software is going to greatly increase the quality of the software, sir.
It's okay. Thank you, Joseph. Professor Singh, are you satisfied?
Yeah. Any other participant?
Professor Singh, go ahead.
Yeah. So, yeah.
Yes,
So,
moderator have one question.
yeah,
The
please.
assistant have one question, please.
Yeah,
Yes.
please.
Yeah, if you can share again the presentation, because I read in the conclusion that you said that data normalization can reduce the dimensionality of the
Let me share again.
of the problem. I don't understand that.
I'm coming, sir. Let me share again.
Joseph, can you hear?
Yes, I want to share the. Okay, sir.
Yeah, in the slide before, in the 14,
Okay.
in the second point, data normalization was used to reduce the high dimensionality of the data set.
That should be a mistake. That should be the smooth. The normalization is just to normalize it to either binary or that. This should be a mistake. Sorry. Did I answer your question? What we use to reduce the high dimensionality of the data set is smooth. I've explained that, sir. The smooth is used to try to balance the data set because we discovered that the data sets, most of them are not balanced. They are imbalanced. So we use smooth to do that. The data normalization will not reduce higher dimensionality. This is it.
Yeah. No, but what techniques they use for data normalization? Can you name the techniques used for data normalization?
The data normalization that I use.
No, can you name the algorithm or techniques through which you have done the data normalization?
I didn't hear you, sir. Hello, sir.
Yeah.
I think, Professor Singh, we have to conclude because two more sessions are
We
there.
have to go for
Okay.
next session
So it
also.
was a wonderful presentation.
Okay. Thank you.
Okay.
All the best.
Joseph, thank
Moses,
you, but in
all the
future,
best.
please mind the time, right?
Okay,
Joseph
sir.
and Moses, it
Who
was a
next
good
one?
presentation, but always keep in your mind,
So
if you will
next one?
not follow the time, nothing will follow to in your life. Please, always mindful. Thank you.
Okay, thank you.
So
Who
call
is
to the
next one?
second presenter.
Yeah.
So before enabling the micro here, before I'm going to stop all the.
Why don't we get the sound from the room and leave this microphone mute better?
Yeah, because the sound is transmitted by this connection. So yeah, that's a problem we are having
Okay.
this open. So
Tell me.
that's why I told you that.
Okay,
So I'm going to try to mute this PC maybe.
I think all the
Yeah.
issues have been solved, right?
Yeah, who is next one?
To choose this.
Okay, let's see. Can you hear me?
Yeah, please share the slides.
I cannot. Wait.
We cannot hear you.
Now we cannot hear them. We need to.
Yeah. Mm, Maybe we can select here the output. You click here, audio settings. Can you test it?
I think.
And the speakers. Yes, and the other, again, the Destro HDMI. And you select them. Select before.
Which one? This one?
No, this one.
This one?
Yes, and now test.
Okay. No.
No, wait.
No.
No.
Change the slide from the badges. You don't have badges.
No.
You have?
You can send it by mail, maybe.
Yes. Okay. Give me an email.
Marcos, this one. This one. Marcos Lupion. L-U-P-O-N.
LUP at.
U-A-L.
Okay. UL.
Not S.
S. Correct?
Yes.
Okay. The email is correct for sure. Marcos Lupion.
Yes.
UAL.SPS. I don't know why it doesn't come.
Yes, it's correct.
Why?
It's sent.
Perhaps spam mail.
Yes, maybe the the mask. So we'll try with this one.
ML
129
129.
U S.
Okay.
No, can you hear us here in the room? Can you hear us, please? The microphone is on. Yes.
Can you hear me, everyone?
Yes, we can.
Yeah. But anyone can answer?
Yeah, please share your screen.
We cannot hear him.
No.
It's
It
not
may be our
visible.
problem. This one. Okay, now I think it's working.
What's the problem?
The problem is that we try to see this one. Yeah, I think Professor Singh, can you tell us something?
Yeah, please.
Okay, perfect.
Okay.
Yeah, it's fine. It's fine.
Hi, everyone. Sorry for the delay. We had some
No
technical
issue.
issues.
Please start.
I'm going to start my presentation now. So, hello. My name is Maria Mafiudaki, and I come from CERT in Greece. Today, I will present to you our recent work comparing univariate and multivariate time series for technical debt forecasting. So this is going to be the main outline of my presentation today for you. First of all, I'm going to say a few things on the technical debt and what it is, how it is created. Second, I'm going to state the problem and describe why we turn towards this research. Afterwards, I'm going to present to you our experimental setup and methodology that was followed. And then I'm going to present to you our analysis and results. And finally, I'm going to conclude our work and describe the future steps that we want to conduct. Okay, so first of all, the technical debt is a term that was inspired in 1922 by Ward Cunningham to describe the quality compromises throughout the software development life cycle that may be for a short time, they bring benefits, but in the long run, they may affect the quality of the software products. But how exactly is the technical debt created? Due to constant technological changes and due to the competition that rises between companies, it is usually observed that companies sacrifice part of the quality of the software in order to bring the product as fast as possible to the market. But this accumulates in the future in the design problems that need to be faced in future maintenance activities. So this additional debt, we call it technical debt, and it's crucial to identify it and to face it on time. So, forecasting the evolution of the technical debt is of paramount importance as it can significantly contribute in decision-making support in estimating the point to which the software product could become unmaintainable in order to be able to take the corrective actions on time. So in our previous work, we have widely employed statistical time series, machine learning and deep learning models in order to generate forecasts for the technical debt. And we have seen that machine learning and deep learning models are indeed capable of providing us with reliable technical debt forecasts, both for short and for long-term forecasting horizons. However, despite the good results that they provide us, they are complex, they lack of interpretability, and are considered computationally expensive. And this is why we turn again towards statistical time series and models, which are the common ARIMA models that we're all familiar with. And More specifically, in the current investigation, we aim to research whether or not multivariate time series models are more capable of providing us with better predictions than the univariate time series models. So when we refer to the univariate time series models, I stated before, we mean the common ARIMA models. And the multivariate time series models are the ARIMAX models that take under consideration exogenous variables apart from the target variable itself. But I'm going to say more on that later. So the experimental setup and methodology that was followed, we utilized the technical depth data set provided by Leonarducci and al. We employed 5 real-world open source Java projects retrieved from the Apache Software Foundation. Now, for each project commit, static code analysis was performed using SonarQube to extract the technical depth indicators as our independent variables, and the technical depth, the total technical depth, which is the dependent variable, the variable that we want to generate forecasts for. And all this static code analysis took place at a project level. And we also applied a filtering process in order to ensure fixed time intervals between the commits, which is generally something that we need to take care of when we apply time series models. We can see here the 5 data sets that we employed, namely it's the Ambari, Commons Codec, Commons ZIO, HTTP Components Client, and Mina SSHD. We can see the corresponding analyzed commits and analysis lifetime. And we can also see the number of the commits after the filtering process took place. So just to note this, we have 1 commit per week. This is the fixed time interval that we ensured through the filtering process. The preparation of a dataset consists of the feature selection. In our previous work, we have explored numerous feature selection techniques, such as filter-based, wrapper-based, and embedded methods. We selected 8 metrics out of the initially 61 software-related metrics that seemed to be statistically significant for predicting the technical depth principle. And we can see some of them on this table, such as bugs, code smells, vulnerabilities, complexity, and so on. And we can actually, it makes sense why these kind of variables are indeed, they act as technical depth indicators. And we also extract the total technical depth, which is the effort to fix all code violations, such as code smells, bugs, and vulnerabilities, expressed in minutes. This is going to be our target variable. So whenever we want to generate forecasts, both for the ARIMA and the ARIMAX models, ARIMA, I say again, is the univariate, and ARIMAX is the multivariate approach, we first need to specify the P, D, and Q parameters. The first step is the identification, which is the step where we need to ensure the stationarity of the time series. And this takes place through the differencing of the time series. Now, the number of times that a series needs to be differenced in order for it to become stationary corresponds to the D parameter. The second step is the estimation, and it consists of the identification of a set of potential P and Q parameters through the ACF and PACF plots. The third step is the diagnostic testing, which is the finalization of the P and Q parameters for each dataset. And this takes place through the minimization of the AIC and BIC scores. And last but not least is the application, where it's the most crucial step, where we apply the best performing model on unseen data. Moving on to our analysis and results, through the 2 first steps, the identification and estimation, we take the 3 best performing models for each of the 5 data sets. And afterwards, through the diagnostic testing, we observe the AIC and BIC scores. And also by taking under consideration the last column of this table, which is the coefficient P higher than absolute Z, we conclude on the best performing parameters, the PDQ parameters for each of the datasets that they are indicated here by the red arrows. And finally, we have the application. So after the specification of the parameters, we generate forecasts for 4, 8, and 12 versions ahead using the walk-forward validation of 3 splits. We use 3 kinds of errors for the evaluation of the models, namely mean absolute percentage error, root mean squared error, and mean absolute error. And we can see here the results for the Amparo Commons codec datasets for space economy reasons, but the results that we obtained from the rest of the 3 datasets were similar to these. So we can see that for whenever we employed the Arimax models, we obtained much lower errors than in the case that we employed the Arima model. So this is an observation that clearly tells us that taking under consideration the exogenous variables, technical depth indicators, in addition to technical depth itself, we take much better results. And in order to visualize this, we generate forecasts for 35 versions ahead for the MENA SSHD dataset. And we can see here that both the Arimax and the Arima model are very close to the ground truth. However, the Arimax model is able to catch fluctuations that the Arima model is not. So in order to conclude our work and describe our future steps, across the 5 datasets that we employed for the current work, we obtained one concrete answer. We observed that the accuracy of the Arimax models was found to be significantly higher than the accuracy of the Arima models. Thus, we conclude that taking under consideration, in addition to technical depth, exogenous variables, which act as technical depth indicators, they are statistically significant for predicting technical depth. In addition to technical depth itself, indeed enhances the model's accuracy. And for our future work, we are planning to generalize these results for broader horizons in the future in order to be able to directly compare the Arimax to the machine learning and deep learning outcomes that we have taken in the past, potentially contributing in the technical depth forecasting field in more ways. These are my references for this presentation. Thank you very much for your attention. If you have any questions, I will be happy to answer.
Yeah, thank you. So any questions from the participants? Any questions? Yeah, you talked about
Yes, sir. Yes, sir. I have one question.
Yeah, please.
Okay, presentation again.
Yeah, it is can you go to the matrices which you have used?
The
matrices. In one of the slides you use the matrices, right? Yes. How can I see the figures? I can't see. Yeah, so have you applied all these matrices?
I'll tell you. You can see the technical depth matrix. These 3 are all of them the total technical depth, effort in minutes to fix all issues. All the rest of them, complexity, lines of code, etc., are the metrics that we use for the independent variables. Here is the total technical depth, which is the target variable.
So, but you have also investigated all these classes.
Yes, as our independent variables. Yes. Yes.
So you've got a very proper formulation. So my question is that, do you think that all those matrices for the technical depth is sufficient? You cannot add more matrices?
We can, but through our previous studies, we have employed, let's say, 4 or 5 feature selection algorithms. The outcomes of all of them, we saw which occur in each of them, and if a metric showed up in every single one of the feature selection algorithm, we take it. So we want to avoid the high dimensionality too, because it brings the curse of dimensionality. So we're trying to put the metrics that seem to be all of them significant, and that's what we did, ending up at 8 metrics. Of course, some other metrics may be also significant, but we saw what each of the algorithms gave us, and we saw, okay, where do the metrics show up? If they show up in all of the algorithms, we take them and use them.
Okay, but do you think that that is a appropriate and 100% foolproof? Because in my opinion, the other matrices can be also useful for the technical depth, because it is a very important point. It is just to show you, just like in the past, software reviews or software inspections are avoided, and this is also type of a technical depth, and you may have some major problems. So I think, and maybe I suggest you that maybe you can also consider some more matrices and then apply, and then maybe based on that one, that we can have some proposal of a new matrix. I'm software metric guy, that's why
of course.
This is also possibility of the new proposal of the new matrices, which can be more useful for the technical.
Okay.
This is my advice.
Okay.
Thank you, sir. Professor Singh, continue.
Thank you. So my one query is, you talked about 3 parameters, P, Q, and D. So what's the interpretation of these 3 parameters?
I can't hear him.
Yeah, you talked about 3 parameters, P, Q, and
So
D.
voice is not very clear.
We can't hear you very well.
Yeah.
I can try to change to this.
Yeah. Can you hear me now?
Yes, it is better now.
Yes. You talked about 3 parameters, P, Q, and D. So what are the interpretation of 3 parameters in respect of your projects that you have taken?
I can't. Yeah, but I didn't understand. Can you please repeat the question?
Yeah, my question is that you have taken 3 parameters, P, Q, and D.
Yes.
So what are the interpretation of those parameters? No?
Is the interpretation of this parameter.
What are those parameters? Can you explain those parameters?
So I don't have them now on top of my head, to be honest. I have to go back and read about them.
Okay. Now, second point is, you talked about technical depth, no? And you mentioned about different matrices, reliability matrix, severity matrix. So severity may be from 2 point of view. One from the customer's point of view also, no? How the software is functioning, no? What's the impact of those bugs on the function of software? So, I mean, you talk about different matrices. So can we consider those things as a technical depth? You know?
So you mean these metrics that I show here? Do you refer to
reliability matrix? You know, you take the example of reliability matrix.
Yeah, from the category of reliability metrics, we only have the bugs, the bugs metric. This is what showed up to be statistically significant for technical depth predictions.
So, what's the meaning of this technical depth? You know, is there a proper standard definition of technical depth? This is the keyword of software engineering. Yeah.
So the technical depth, as I mentioned here, generally it describes the problems, let's call it like that, the problems that we have in the software product. It's a very useful quantification of the problems that occur in the software that in the future they will need to be faced. Someone will sit down, a person is going to sit down and is going to try to fix the problems. And in fact, if you see here, the total technical debt as extracted from the SonarCube static code analysis is actually the effort to fix all code violations expressed in minutes. So it is actually, let's say, a time in minutes that is calculated through static analysis that someone is going to have to sit down and spend half an hour, 2 days, 3 months to fix all code violations in order for this software product to be maintainable.
Okay. So have you considered the different levels of bug severity also? I mean, some bugs may be easy to fix, some bugs may be difficult to fix, like the severity level of bugs from the developer's perspective.
This is something that we do not know, as this is a static code analysis that takes place behind closed doors. So I personally don't know exactly how SonarCube does this analysis, and I cannot answer that. I just take the results from the static code analysis in numbers, and I'm saying, okay, SonarCube calculated it like that. I trust SonarCube. I trust that it calculates that I'm going to have to spend this much time to fix this code violation.
Okay, thank you.
You're welcome.
Good work.
Thank you.
And
thank you.
Congratulations for your future research work. So thank you.
Thank you.
Thank you. So
Well done. Very nice.
well done.
So go for the third presentation. Pretty good job.
Thank you so much.
Because it's very rare. I mean, it's a matter of reliability. It's working on the reliability.
So who is next one?
Hello, can you hear me?
Yeah, please.
Let me share my screen.
Yeah.
Yes. Well, thank you. Good advice for the future.
Wait a second. Can you see my screen?
Yes.
Right. Hello, my name is Mark Loiko, and the goal of our paper was to test if it is worth fine-tuning GPT-2 for repairing bugs or not. In our previous paper, we used GPT-2 to generate patches for bugs, and in this paper, we compared the results of the fine-tuned model and the pre-trained model. In this slide, we can observe the high-level approach. First, we split up and preprocess the JavaScript files. After that, we fine-tune our model, and the fine-tuned model and the pre-trained model are used to generate candidates separately. The generated candidates are compared to the developer fix, and then we evaluate the results for each model. The preprocessing and the patch generation is the same for both the pre-trained and the fine-tuned models. So let's go to the preprocessing part. We form the dataset so it is suitable to be the input of our model. First, every comment is being removed since they do not affect the execution. Then we split the dataset into training and evaluation split. Then each of them is preprocessed. The main difference between the two preprocessing is that the evaluation split does not contain the code after the bug location. The GPT model's input is a simple text file in natural language processing. There is no target like in classic supervised machine learning. The model itself can learn on plain text to generate additional text. In our paper, the model's input is a simple text file, as in natural language processing, but instead of text, it trains on source code. In this text file, in each line, we have a part of a code belonging to one of our training sample. This part of code is an interval of tokens around the bug location from the fixed file. 90% of the training data was used for training, and 10% were used for validation, where early stopping was performed. So patch generation. From the evaluation set, we generated candidates for each bug. The input for our generation function was a specific length of tokens before the bug location, and we used GPT as we would in code generation to create new candidates. We used GPT's modified generation function 5 times, and in each generation, we generated multiple lines. The maximum number of candidate lines per generation was 10. But we only observed 5. So the results of the GPT model to generate patches automatically. The upper table showed the results of the fine-tuned model, and the lower table showed the results of the pre-trained model. In each generation, the model created a list of patches. We consider the generation in an accumulative fashion. If we consider the first generation and the top one result, only one patch is examined. In contrast, in the fifth generation, there are 5 candidate patches, 1 patch per generation. In this sense, the top one result in the fifth generation includes 5 candidate patches. The abbreviations are the following. EM stands for exact match, ED stands for added distance, and the number is lower added distances than that number. So the candidates with the character differences are less than the number itself. So from this slide, we can already answer our question, which was if it is worth fine-tuning GPT-2 or not. We can clearly see that the results are much better after fine-tuning. So we will talk about this in the conclusion part. And we will see a few examples of the qualitative evaluation results. These examples of correct fixes generated by the fine-tuned model can be found on the left side, and the fixes for these samples generated by the pre-trained model can be found on the right side. We can stay here for a second, and you can observe the generated patches. We can come back in the end if you want to see it again. These are examples of correct patches generated by the pre-trained model. This is the left side, and on the right side, there are fixes for the samples generated by the fine-tuned model. And these are patches generated by the observer models that are nearly identical to the developer change. So in book 37, for example, we can see that both the pre-trained and the fine-tuned model is capable of generating nearly identical regular expressions to the target. So the conclusions are, we generated patches for 1,559 bugs with pre-trained GPT-2. We compared the results to our previous work, where we generated patches for the same bugs after fine-tuning the same model. While the fine-tuned model was able to generate correctly 126 programs on the first try. The pre-trained model was only able to do it in 10 cases. When both models had multiple chances to generate patches, the fine-tuned model generated correct patches 269 times, while the pre-trained model only in 27 cases. So we concluded that the fine-tuned GPT-2 model performed a lot better than the pre-trained one. Thank you for your attention.
Thank you, thank you. So, any comment, any query from the participants? Professor Misra, would you like to comment?
Okay.
Yeah. So,
The microphone.
Ask this person.
yeah. So, by one query, you have generated patches for different bugs. So, is there anything that that program consists of different programming constructs, maybe in the loop or if else or some statements. So your patches, they are more accurate in case of one kind of programming construct, loop or if else, normal statements. Have you done any kind of?
Sorry, I can barely hear you.
So can I repeat my question again?
Yeah, sure.
So my question is that you generated patches for different bugs. Huh?
Yes.
I suppose that some code will be generated for fixing those bugs, right?
Sorry, I can't really hear you.
Can you hear me? Can you hear me?
Yeah, it's good now.
Now it's fine.
Can you repeat it, please?
My question is, you have generated patches to fix different bugs. Yeah, and you generated some kind of code, source code.
Yes, source, yes.
Yeah, fine. So have you gone through that? Which type of programming construct, maybe that loop or if else or statements your patches are doing?
So, is the question if the question was to how do we decide the target text, like
Target text.
yes, we didn't use bug localization, but we used the already made fixes where we could see what is the perfect target text, and then we generated source codes and we compared that source code to the target text we already saw, and that's where we used edit distance to evaluate it.
That's perfectly fine. Perfectly fine. Means you are generating automatically patches to fix different kinds of bugs.
Yes, with
That's fine.
GPT-2.
That's fine. So once you are going to generate patches, so patches are more efficient in case of which type of programming constructs, in generating some kind of loops or if else or some statements like that. This is my question.
Can you repeat it, please?
So my question is that your patches are more accurate or more efficient in terms of what kind of programming constructs, maybe generating a kind of loop or if else or statements. Suppose you want to fix a bug, so maybe you have to change some loop or change some if else statements or changing some statements. So there are different kinds of programming constructs. So what kind of uh, code generated by your automatic code generations are more efficient?
So was the question if what kind of bugs did we fix, like loops and something like that?
That's fine. That's fine.
We can.
There is a concept of bug fix pattern. Bug fix pattern means suppose you want to fix a bug. So what type of changes you want to do? You want to make changes in loop or if else or the statements, like that. So that kind of depth study also you can do. That you are generating patches. So your patches are more efficient when it is generated to fix a bug which require change in loop. Your
So
patch is more efficient when you are going to fix a bug. You want to change some kind of branch in if else. or you are fix a bug and you are generating some text, and it is more efficient if you are generating some kind of statement. You can
So,
the analysis of the image.
so when we try to fix a bug with GPT-2, we observe the code before the bug we want to fix, and the model itself can predict for loops or if statements based on previously seen data where it also had to generate if statement or for loop, so it will find out, and it will also be able to, mostly not all the time, but it will figure out what is the variable for the for loop and so on.
Yeah.
So
So
with a lot of data seen, it can predict some complex data structures like for loop and even regular expressions, as we could see.
it's good work, no, and also in future you can do a lot of work in this area. It has
Yes.
it has potential to do good work.
Thank you.
Okay, thank you. So, any other comments from the other participants? Are okay, thank you and all the best. All the
Thank you
best.
for the attention.
All the best. All the best. So, anyone is left for presentation?
Yes, is it over?
Yeah, it's over. It's over.
You have any questions?
No, I don't have any question.
Yeah.
Thank you so much, sir. There is a
Okay.
half an hour break for the
Yeah,
tea.
yeah.
I offer you, please come and join to the coffee break with
Thank
very beautiful cakes of the Malaga.
Oh,
And also, you know that there are several European duties are there
yeah.
with
That's right.
cookies. Come and enjoy, right? I'm expecting you since several years, and you promised me to
Yeah.
come to the Malaga, and you have not come.
Next year solely I will come. Huh?
Please come. So we are meeting after half an hour, right?
Yeah, sure. Okay,
Okay.
thank you.
10:50 is the next session.
Yeah, thank you, sir.
Yeah,
10:50,
10:50.
right?
Yeah,
So
half an
half an
hour.
hour break. We are meeting at 10:50 for the second session, and
Yeah.
I think you are chairing only 2 sessions today, right?
Yeah. Okay.
Thank you so much, sir.
Thank you.
Please be in time, right?
Thank you, sir. Thank you.
I will be there. See you.
Sure.
Half
Thank
an
you.
hour there.
Thank you.
Thank you. Bye.
So said about this, what how to do, because I didn't understand exactly. We can. Okay, perfect.
Hi. Professor Singh?
Yes.
Yeah.
So,
If you want, we can start.
yeah, we can start. Yeah, I'm here.
Okay, thank you.
Yeah, please.
Hi, Prof.
It is 40.
Yeah.
Camera is started.
Yes, the chair is Professor Singh.
Yes, yes.
Okay.
I'm the chair, but it's, this is my
okay.
one. It's okay. Professor Singh is going to chair.
Okay.
Yeah.
Sit down, no problem.
Thank you.
Professor VP Singh, are you here, right? Thank you
Yeah,
for coming again.
Yeah, I'm here. Yeah.
So let me check that who and who are present. Where is the program? I open it here, my dear.
Okay.
ICCSA program. Where is the plan? Over. So Peter is there. Norbert Vander, welcome to this after tea break session. Have you on it?
Yeah.
Hello, yes, I'm here.
Yeah. So first presenter is there, right?
Yes,
Okay.
Okay. Means Norbert, right?
yes,
Yes. Welcome, Norbert. And I hope that the second paper is also from in your university, right? Okay, you are both.
yes.
You are a presenter in both papers, right? You have the two papers.
Yes, I'm the first.
Okay. So, and the third one is also there. Yes, I know Anisha Kumari is there, and then Moses is he will come. Joseph. Yeah, he is there. So all the presenters are there in the session. Professor Singh, I'm here
Yeah.
to help you. But
Yeah. Okay.
take your seat and you are
I'm
welcome
sorry.
again. Thank you so
Yeah,
much
thank you. Thank you so
for
much.
sharing the session.
So, Narwat, you
The
can share your screen.
Professor Singh,
Yes. So, yeah, you can start your presentation.
yes, you
Okay.
can start. Two of them from University of Sajid, from Hungary. They are my authors. A long, I think more than since 2008-9, they are submitting the papers. So the both of presenters are from same presenter, but first two papers. Third one is from BITS. This is from NIT Raurkela,
Yeah.
Anisha Kumari. And the fourth one is from one of my students from Nigeria and Moses,
Good.
right? And all of them, they are present.
Yeah.
So the floor is yours.
Yeah. Please start.
Okay?
Okay.
So I'm going in the back.
Yeah, no issue. So, just to share your screen.
Can you see it?
That's fine.
Okay. So my presentation will be about comparing machine learning-based predictions and static analyzer tools for vulnerability detection. As we all know, software security is very important since nowadays software systems are shaping many aspects of our lives. And to increase security, developers should find and eliminate vulnerabilities as early as possible during development. One way to do this is by using static analyzers, so tools that find issues in the source code without actually running it. There are many widely used static analyzers, but for this paper, we looked at 3 of them. They are Node.js, Scan, ESLint, and CodeQL. Another way of finding vulnerabilities is by using machine learning-based models. While there were numerous comparisons between tools in the past, and they always focused on only one type. So they compared static analyzers to static analyzers and machine learning to machine learning, while in this paper we compared the machine learning to static analyzers. And that machine learning based model is one we have proposed in one of our earlier works. We made it with the goal of finding vulnerabilities in JavaScript systems while both being granular and explainable. Granularity in this case refers to it being line level. So the tool looks at individual code lines instead of larger blocks like functions or files, as is the usual for these tools. It works by creating a knowledge base, so a database of known vulnerabilities, and a Word2Vec model to turn the code lines into vectors. During the prediction process, the line in question will be vectorized and then compared to the lines in the knowledge base to find the line it is most similar to. The probability of a line being vulnerable is calculated based on its distance to the most similar line and some other rules like the complexity of the line. Our goal here is to answer the following question: how does our method fare against other popular analyzers? In more detail, we will focus on 3 aspects. One is the quality, so how many vulnerabilities can a tool find. 2 is time, so how fast can it do it. And 3 is which is the most detected vulnerability type. And to be able to compare different tools, we used the Open Source Security Foundation's CVE benchmarking tool. CVE is short for Common Vulnerabilities and Exposures. In other words, it's a list of publicly disclosed software security flaws. And CWE, which we will get to later, is short for Common Weakness Enumerations. So it's a group of CVEs. The benchmark itself consists of code and metadata of over 200 real-life CVEs from over 200 GitHub projects. In total, there are more than 200 affected files, which translates to over 200,000 lines of code. For proper testing, it is invaluable to use examples from real life instead of synthetic test code. The benchmark uses drivers to run the different tools on all CVEs, both before and after they have been patched. The drivers were provided for the static analyzers, but for our own tool, which we called Von.js for line, we had to make one ourselves. After running, the benchmark determines a few things like, was the tool able to detect vulnerabilities or did it produce a false negative? And when run against the patched code base, did it recognize the patch or did it produce a false positive? Now for the results. As mentioned earlier, one of the aspects we focused on was the prediction quality. You can see here the results of the different tools. There are 3 categories. Red means the tool did not detect any vulnerable lines. Orange means that while it did detect vulnerability, it flagged the line as vulnerable again, even after the patch was implemented. And green means that it correctly flagged a line as vulnerable and then removed the flag after the patch. However, the benchmark doesn't take into consideration the lines that are not part of the vulnerability. As you can see, our tool finds the most vulnerable lines, although it produces more false positives than CodeQL, so we consider our tool to be the second best in this category. Another important metric of the quality of predictions is the number of lines a tool flags. Unfortunately, this metric is not included in the benchmark reports, but we calculated it because we found this to be important. Since, as mentioned earlier, the benchmark ignores flagged lines that are not part of the vulnerability. So if a tool were to flag every single line, then according to the benchmark, it would produce 100% orange rating. As you can see from the figure, our tool flags the most lines, a little less than 100 on average. However, since the files in the benchmark are 1,000 lines long on average, this means our tool only flags around 10% of them. So while this can still be considered high, it is something that can be improved upon in the future. The next metric we examined was the time it took for the tools to produce a prediction. And this metric is also not present in the benchmark, but we deemed it important enough to calculate it, since it's one thing to find vulnerabilities, but we should be finding them fast. As you can see from the figure, our tool took around 6 minutes on average to produce a prediction, while, for example, ESLint only took a few seconds. So while this reduces the real-life usability of our tool, it is important to note that it was written in Python, which is known for its slower speed. But it is also something that can be improved in the future. Also, due to an unknown error, we could not measure the speed of Node.js scan. And the last metric is the most detected vulnerability type. Related literature states that static analyzers are better at finding certain types of vulnerabilities like SQL injection or cross-site scripting related vulnerabilities. So we were curious whether our tool showed any preference to certain vulnerability types or not. As mentioned earlier, the benchmark contains the CWE categories for each CVE, and this table summarizes the percentage of vulnerabilities that were found for each CWE. These are not all of them, only those that have occurred more than 10 times. We again had to omit Node.js scan since it found too few vulnerabilities to be able to make a meaningful comparison. We can see that in multiple cases, one tool clearly outperforms the other, like in the case of CWE 116 or 88. This means that it is a viable strategy to use multiple tools at once to maximize our chances of finding vulnerabilities. And this also means that since certain tools are better at finding vulnerabilities of certain types, it is better to use those tools when we exclusively want to find vulnerabilities from that specific category. So in conclusion, we presented a machine learning-based tool for finding vulnerabilities, and used the benchmarking tool to compare it to static analyzers, we found that our tool was more than capable of finding vulnerable lines, managing to find 60% of all vulnerabilities present in the examined dataset. We also showed that it is capable of finding vulnerabilities that other tools would likely miss, as it has a higher likelihood of finding issues belonging to certain CWEs, which the others find significantly less of. However, it also has some limitations, mainly the high false positive rate and the time it takes to run. But in the future, the tool can be improved on those fronts. Thank you for your attention.
Okay, thank you. So any comment, any query from the participants? Okay, you talked about different kinds of tools that are being used for the vulnerability detection. So can you name some predictors, some possible predictors for this vulnerability detection from the source code of any software project?
I'm sorry, could you repeat the question?
Yeah, can you name some predictors for the vulnerability prediction?
Besides the three we have used?
Yeah.
I can't name them from the top of my head.
No issue at all. So what's going on latest work in this area?
Yes, as mentioned in the presentations, there are some issues with this tool, and we plan on improving upon it. For example, adapting the tool to a language that has a faster computation time, for example, C++, to make it more usable in a real-life scenario.
Yeah. So these are very practical applications, and also in industry also people are using all these tools. No? So you are working in the area of this prediction or detection?
Presenter, if you have done, I don't have any question.
Yeah, okay.
Because he is the presenter, he is the same presenter.
So he's going to for the next presentation also, right?
No. The next presenter will be Balázs Mosolygó.
Yeah. So please share your screen. Yeah. Okay, thank you.
Something?
Hi, everyone. Should I share the screen now? Or are you still?
Use the bar because
Can you hear me?
Yeah. Share your screen.
All right. Okay. One quick second. Right. Hopefully you can see everything.
Yeah.
Okay, perfect. Yeah.
Okay. So I'm going to be presenting our, let's just say, parallel study that we did about a very similar topic, which is still about the same detection algorithm. I'm going to explain it naturally once again, just so if someone missed the previous presentation, they will not be lacking in the ability to understand what has gone on. And I will also repeat some important notes about software security. Of course, it is a very important topic nowadays. We have seen large amounts of financial damage done, personal information compromised because of a lack in software security. There are many attempts being made right now, and there are many professionals working in this field. However, we must understand that, of course, an automatic system that could detect these problems upfront would improve the reaction time of companies running these systems, and also would reduce the amount of manpower needed to be dedicated to trying to find these issues, given the fact that if the tool is capable of finding them faster and more effectively than humans can, humans could focus on fixing these issues, which with tools right now is pretty difficult. Little bit about our previous results. We have created a word-to-vec based line prediction model that has been whose capabilities have been presented in the previous presentation. It is capable in the JavaScript environment to flag only 22% of lines by finding 41% of vulnerabilities. This means that it only flags 1/5 of the lines and finds half of the lines that are connected to some sort of vulnerability. Our current goal was in this study to try and recreate our previous results in a new environment, specifically in Java, because Java is a much older language, a much more mature language, meaning that there was a larger amount of test data that we could use to both possibly improve the capabilities of our models, test its limits, see if it is capable of achieving the same things, see if our previous measurements were fair, given the fact that our JavaScript database was
your slides are not moving, I think.
Excuse me?
Yeah. You are on the same slide. Yeah. It's moving.
I didn't get to the next slide yet. There I will explain the algorithm, or I don't understand the question.
Yeah, please continue.
All right.
And I took all of your pages to me in the first day.
Okay. So the original algorithm, as explained before, uses a database, this time from Java, that contains vulnerable lines that are lexed. Lexing means that they are tokenized practically, and based on this tokenized vulnerable data set, it creates predictions for vulnerable lines. It is a pretty simple system. It does this for every single line, meaning that every single line will be compared to the entirety of the VLR, which is important for understanding the later issues. And it also tokenizes the system that is under test, meaning that tokenization happens often and it happens every time. There were two issues that we needed to look at. The first issue was the reduction of the VLR's size. This was needed because, as I have said earlier, every single line of the VLR needs to be compared to every single line of the system under test. We had a much larger VLR in the case of Java that has led to the tool running excessively slow, and which is of course a problematic thing given the fact that this tool is meant to be fast and quick, capable of producing results efficiently. Another issue was that the first results were extremely, let's just say, inefficient, because the Java language is relatively verbose compared to JavaScript specifically, meaning that a more expressive tokenization system needed to be implemented in order for the new tokenized lines to better explain how the language looks like. That means that, for example, we will see, I will talk about it more in depth. But it's also important to know what kind of metrics we have measured. Of course, we have measured how many files we have flagged, how many file lines there were, and of course, how many vulnerabilities have been found. All of these are excessively important given the fact that, of course, you can't know if flagging 100 lines in a file is good, if the file is made of 100 lines is bad, if it's of 1,000 it's not so bad. And on to our results. The performance of the direct port, as I have alluded to earlier, was lackluster. It flagged too many lines and created too few true positives. It actually found far less vulnerable lines than expected than it has before. However, the rules were also making a difference here, as I don't think I have explained those before. We have used two rules. One of them preferred more complex lines. This one didn't perform as outstandingly as it did in JavaScript, which is not surprising given that the average line is more complex than in JavaScript. In Java, the average line is longer, meaning that there is a higher chance for it being perceived as complex than in JavaScript. The other rule prefers lines, makes their probability of being vulnerable higher if they are surrounded by vulnerable lines. We have, first of all, we have reduced the VLR. We have done this so that in a way that we have hoped its capability of presenting vulnerable lines would stay similar, while its size would be greatly reduced. We can see that we have made two levels of reduction. One of them was a 0.01 minimum Euclidean distance reduction. This has been done by getting non-vulnerable lines from the systems that we have tested. We did this by finding the lines that were made to fix vulnerabilities and presume that these would be versions of the lines that are not vulnerable, and went through the entire VLR and eliminated lines that were either 0.01 or 0.1 distant from the lines in this non-vulnerable line repository. We can see that both of them, we can see that both of them produce reductions. The slide doesn't contain, but the original VLR contained 70,000 lines. Even the 0.01 reduction reduces that to 3,200. And our results with the reduced VLRs show that both of these are at least useful. The 3,200 line actually produces identical results to the one that was not reduced, meaning that its predictive power with this VLR is the same, while the more strict version, the 0.1 version, decreases predictive performance. However, it is an excessively large reduction. It contains less than 1% of the vulnerable lines. The augmented VLR is the one that contains the more sophisticated tokenizing system. This one, in this one, we make a difference between different identifiers. For example, if it is a function name identifier, we name it as such. And because originally in Java, for example, we have extremely complicated lines, which when there are continuous calls, and in this it is beneficial if we know that one of them is an object, another one is a variable, and the third one is a function. This increased the predictive performance greatly and helped us create the results we have sought, meaning that this one is comparable with the original predictor. So I will bring this all together. Basically, we have created a method which we have managed to port this method from JavaScript to Java and make it so that its performance is similar. We did this by reducing the VLR by large amounts. This means that this VLR can be reduced, first of all, and second of all, that its reduction leads to similar performances. Both of these are important, given that one might assume that with a solution this simple, it would be important to have as large of a VLR as possible, just so it is capable of finding as many vulnerable lines as possible. We have also found that introducing more token types, at least in Java, helps a lot with the model's capability to recognize vulnerable lines. With this knowledge, we might in the future either branch out to new languages, try and extend our original method to include these new techniques, and we might also continue to improve our Java method just so it is capable of producing maybe better results, because with the larger information set, it is easier and more valid to produce the results and the measurements that we showcase. And that's pretty much it. Thank you for your attention. Any questions?
So thank you so much. Thank you. Any questions from any participants? So you mentioned about true positive. What's the interpretation of true positive in your research case?
I am sorry, I am having difficulty understanding you. What did I talk about before?
Yeah. What's the interpretation of true positive in your research paper?
What? Sorry.
Can you hear me?
I can hear you. I just don't understand the word that I.
Yeah. What's the interpretation of true positive?
True positive.
Yeah, in your this research paper.
I'm sorry. I'm gonna try and.
You mentioned in the result. You mentioned about very few. No, go on the conclusion slides.
I'm sorry.
You go on the yeah. Next.
Here, this one where I'm talking about 2 levels of reduction. This one.
No, true positive. Mentioned about true positive.
I don't know what that is.
Maybe previous go on previous slides.
This?
No, previous. You mentioned no slides. No, true positive. Yeah. Creates few true positive. What's the interpretation of this?
Yeah. Professor Singh, also there are some comments in the comment box.
Yeah.
Please read and ask to the authors to clarify.
Oh, okay. I'm truly sorry. I would be ready to answer your question. I just truly don't understand. Maybe if you could type it, I would know what you mean. I'm sorry.
No, you mentioned that very few true positive. So just I want to know the interpretation of that true positive. So there are some questions on the chat box.
All right, I'm going to answer the question.
Please
mention one of this.
Yeah.
Okay, so the question is that time is a limitation of our system.
So yeah.
Yes. So the reason we have previously said that it is relatively fast, however, this time we are saying that the time is a limitation here, is because of the fact that the algorithm the algorithm's complexity is quite poor, meaning that it is close to n squared. If the vulnerable at odd one squared, meaning that if the VLR grows too large, it becomes exponential and then it's extremely slow. Meaning that if the VLR is too large, it can quickly scale out of control in terms of time. However, we still make the claim as to its effectivity when it comes to time, since as I have shown in my presentation, the size of the VLR can be reduced to a couple of thousand lines instead of like 70,000 or 100,000, meaning that, and with that reduced size of the VLR, it is still faster than most other prediction models. Basically meaning that if one does not use it too large of a VLR, it is still faster. However, one must be really careful as to adding new lines to the VLR because the time complexity can scale out of control. This is why it is both an asset and a curse in this model or in this method.
Okay, thank you. Any other comments or queries? Okay, thank you. All the best. So we'll go for next presentation. It's Anisha. Are you present?
Ranjan Bahera will present.
Ranjan, please.
Am I
Please
audible,
share your
sir?
screen.
Yeah. I'm sharing my. Just a minute, sir. Just a minute, sir. Yeah. Is it visible, sir?
Yeah.
That's
Mhm.
Yeah. Good morning, everyone. This side, Dr. Ranjan Kumar Behra, and our work is about role of serverless computing in healthcare system. Am I audible, sir?
yes, you are audible.
Yeah. Okay, sir. So our work is related to role of serverless computing in healthcare system. So how the serverless computing will help in different healthcare system, and we have presented some of the case study here. And what exactly is serverless computing? It's a new kind of computing paradigm in case of in cloud computing. It's describe a way for companies to build and run applications without having to manage the infrastructure. So user only have to write the code and submit the code and deploy the code, and the rest of the thing will be taken care by the cloud provider. The infrastructure management, the what language it will be used to run the programs, and what uh, what resources is needed. Everything will be managed by the cloud provider. So all the responsibility will be removed from the client side to the server side. That is the main advantages of this serverless computing. In serverless computing, it doesn't mean that server is absent. Server is actually present at the backend, but all the managing responsibility and all that in provisioning, scaling, and maintenance responsibility that will be taken care by the cloud provider instead of developers. Developer only needs to focus on the code so that it can save time also, and scaling will be automatic. Whenever any more resources is needed, that will be automatically it will be scale up, and whenever it is not required, it will be scaled down. And the most interesting thing is serverless computing is you have to pay for only for what you have used, what you are using. I mean, suppose suppose a server is provisioning to you, but you need not to pay for whole server. You have to pay for only the memory uses, means whatever the memory you are using or whatever the resources you are using, exact amount of resources consuming. Only for that you have to pay the price. So if you see the evolution of this serverless computing, so we'll start from the data center, where the abstraction level is the physical, where usually everything has to manage by the users, and then IaaS come into the picture, infrastructure as a service, where where the scaling will be based on the operating system is, and the hardware is abstracted, and then platform as a service came into the picture, where the application or the unit of scaling is the applications, and all the configuration about the operating system that will be abstracted away. And in serverless, unit of processing will be function rather than application. The unit of processing in serverless is a function. So that's why another deployment service is there, which is known as function as a service. Serverless is otherwise known as function as a service. And even here, the runtime language is also abstracted. So these are some of the key features of serverless computing. You need not to manage, no server management is necessary. So developers are only charged for the server space they use, reducing the cost. So exact amount of resources a user or developer is using, then user has to pay only that amount of resources. Only so serverless architecture are inherently scalable, and quick deployment and updates are possible, and faster to market because everything will be based on the function. And suppose you are asking them to I want that function to execute, so only that function will be executed in a separate container, so development will be more faster, so the product will be prepared much faster as compared to other deployment model, and the code can run closer to the end user. You don't know where the actually your code is running, in which server your code is running, you don't know. So that code can able to run very nearer to you, so the reducing the latency, so the response time will be very less in serverless computing. And very important feature of serverless computing is that each of the functions are stateless in nature. That means after execution of the functions in a separate container, the state of the function will be lost. Okay, so that is one of the, you can say, one demerit also as well as merit also. Merit is that the function will be executed much faster as compared to other deployment environment. And if you see about the demerit, then you can say state or loss. So to run a different functions, it will take a little bit more time. So this is the main difference between the serverless computing and cloud computing. In cloud computing, what happens? The resources need to be allocated in advance, whereas in serverless computing, the resources will be allocated on demand. Whenever resources is required, at that time only resources will be allocated. Unlike cloud computing, where the resources are allocated in advance. In cloud computing, you have to pay for your server, whole server you have to pay. But in case of serverless computing, you have to pay for the exact amount of resources that you are consuming. Only for that resources you have to pay. So cost will be also less in serverless computing. That means in cloud computing, suppose you are borrowing some server, you have, whether you are running your program on the server or you are not running on the program on the server, if it is idle time, you have to pay for that also. But in case of serverless computing, you don't have to pay for the idle time. And scaling needs to be done in case of cloud computing, but the scaling is automatically in case of serverless computing. That is the main advantage of the serverless computing. And this is the architecture behind serverless computing. So uh, client will be request something through a API gateway, and each processing unit will be functions, and then the red color is termed as the warm-up startup, and the blue color is represented for cold startup. Cold startup means whenever you want to execute a functions, it needs a new container. It needs a new, suppose the function is not executed before, so it needs a new container. So library setup, environmental setup, that will take some time. Some more time it is required to start up the functions. So that delay is known as cold start delay, okay, which is one of the major disadvantages of this serverless computing. Okay. So for that, to remove that hurdles, some warm-up setup can be possible. So that means after execution of the function also, for some time, keep the container warm, so that no need to initialize, no need to set up the library again and again, so that that same container can be used by the other other functions. So main thing is that the unit of processing is function in case of serverless computing. And whenever a user want to execute some function, it will be executed through a event, and that event should be triggered by the client side. Client will be trigger some event, and event, the example of some event will be like you are deleting some row in a database, or you are requesting some HTTP request or something like that. Something, anything you have to do, that will be defined by the client only, developer only. And the serverless computing is also known as function as a service. If you see, in case of infrastructure as a service, everything will be managed by the developer side, and only infrastructure will be managed by the this cloud provider. This blue color is say that that is managed by the cloud provider, and all the things will be managed by the developer. So in case of infrastructure as a service, almost everything will be needs to be managed by the uh, developer. And in case of platform as a service, the functions, data, and application only have to manage by the developer, and rest of the things like runtime language and operating system and infrastructure will be managed by the cloud side. But in case of function as a service, only you have to manage on your development code. You have to manage your function and data only you have to manage, because here the process here the unit of processing is the function. So that's why you have to manage the function and data only. The rest of the things will be managed by the cloud provider. So these are the very applications where the serverless computing are widely used: web applications, data processing applications, and for batch processing. And in case of IoT based application, in case of where the data is very sensitive to time, means where time is very sensitive, there we can use serverless computing. So healthcare is one of the very crucial application where the time is very important. Means your response time should be as minimal as possible, because it can save somebody's lives. So it is dealing with some life. So that's why in healthcare application, many use cases are there where serverless computing have been used. And for event-driven application are very useful. Mm, event-driven application also serverless computing are very useful. So these are some of the applications that are used in cloud-based applications are there. E-health and telemedicine, drug discovery, and healthcare information system, personal health record to managing the personal health records, clinical decision support system. These are some of the applications related to healthcare system which are usually managed by the cloud-based application. These cloud-based apps are developed to manage these applications. And yeah, this is the architecture for serverless architecture for healthcare manager. This is the overall architecture. Basically, this is the architecture for an application for developing a web-based patient portal. Patient portal where the patient informations, where the patient can enter his information, and that information can be used by the doctors or the healthcare service provider, and that can be used to give better services. So some of the modules for some of the serverless modules which are integrated with this web application are AWS EC2 and AWS Amazon Web Service Cognito and S3 buckets and integrator is there. And some of the analytics can be done through the serverless computing models. And usually what happens in S3 bucket is used for storing healthcare record, the electronic health record that will be used to store, that are usually storing in the S3 buckets. And AWS Amazon Web Service Cognito, that is mainly used for authentication purpose. It is providing a key token to make the user authenticate. And EC2 Amazon EC2, that is used to provided resources, different types of instances it will be provided, serverless instances that will be provided to web portals. And this front end, this is the first one is the front end user interface web application for patient portal, and this is the back end for patient portal back end for application that will be connected to MySQL databases, which will be managed by AWS Aurora. One one module is there, AWS Aurora. One component of serverless component is there. There are many vendors are there which are providing serverless framework. The major vendor is the Amazon Web Services, and the Google also has platform for serverless, and Microsoft Functions, Azure Function is there providing healthcare services. So let's begin with the case studies. First case study is the first healthcare interoperability resources. It is one kind of software system that provides standard and application programming interface for exchanging electronic health record between the computer over the internet. So what happens whenever a patient is coming to the hospital or whenever patient is registering, it come across different IT system. These IT systems should be communicate effectively so that that patient will be taken care carefully. So for this is the FHIR, the first healthcare interoperability resources. This is a one kind of software system that provides standards and application programming interface for exchanging electronic health record. They use AWS serverless framework. They are mainly used to focus on fast and easily implementation of different models of healthcare sector, and it is totally free with no restrictions. Different kind of formats they are using to exchanging information from one system to another system. That can be either JSON format or XML format or OAuth format or HTTP format. So it is supported by many of the companies, Apple's, Microsoft, Google's, and many other vendors are supporting this FHIR, the first healthcare
Yeah, can you
interoperability
expedite,
resources.
Ranjanji?
Yes, sir. Yes, sir.
Yeah, please, please.
So this is architecture for FHIR. So the unit of transmission is the known as resource, where the messages are transmission from the one system to another systems. So major component of this serverless environment for this FHIR is the Lambda integration, Lambda functions, and AWS DynamoDB and AWS S3. Here two storage components are used generally. In AWS, DynamoDB is used to store the data in the form of key value pair, but in case of AWS S3, the data are stored in the form of objects. And AWS X-ray is also used for tracking the message flow between the two computers. And Cognito is used for authentication to generate an authentication tokens. And repository AWS DynamoDB and AWS S3 is used. And client can be interact with a FHIR endpoint, that is the API. So these are the different components that are used in FHIR. This is AWS Cognito and AWS X-ray, AWS S3, and DynamoDB. And CloudTrail is used to log the audit, and Lambda function is used to develop the interfaces or different service application, healthcare service application in case of FHIR. So similar to FHIR, another case study is there which is using serverless architecture, that is IoT based remote monitoring systems. Usually, four steps needs to be taken care in case of this remote healthcare monitoring system. First, IoT will be used. So sensor will be used. First, you need to decide how many things are required to connect to get the primary data, or the raw information needs to be collected. That information needs to be transformed to the analog to digital signal, and that should be linked to the internet. And then the pre-processing will be done. In the third step, pre-processing will be done. And the fourth step, the process data should be analyzed and stored at the back end in the cloud. So for this, each of these four things, we need the serverless components. So this is the architecture for remote healthcare monitoring systems, and here IoT core will be used, and the NoSQL databases will be used. So that will be managed, and 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 another model is there SNS. Some another model is there for anomaly analytic. Whenever some anomaly occurs, that has to be notified to the doctor or to the patient health staff through the SNS or emails. So simple notification service. SNS is one kind of simple notification service provided by the AWS and serverless platforms. This is a simple architecture for remote healthcare monitoring system. And these are the various components generally used for the
Ranjanji, please,
remote
please
healthcare
conclude.
monitoring
Please
system.
conclude.
Yes, sir. Yes, sir. Yes, sir.
Yeah, please continue.
So one more was there. Data lake was there for serverless monitoring. Data lake is mainly used to storing the different kinds of data. Either it can store the structured data, semi-structured data, unstructured data, like that. So these are the different components used in case of data lake. Data lake is one kind of another case study for which is using serverless platform. So the requirement whenever data is time sensitive, requirement for time sensitive analysis and quick deliver service of the healthcare that demands for the serverless framework. Whenever quick delivery is required, the response time is to be required to be very fast. So at that time, serverless is required. Serverless framework is required. Unpredictable amount of server loads leads to be serverless architecture. Yeah, and quick changes whenever changes is required. At frequency of changes is very high. At that time also you can use serverless because here the unit of processing is function rather than application. So there will be very less effect on the original applications. So some of the primary reason for using serverless framework is it provides better security, reduce cost, and enhance performance and faster time to market. That's it.
Okay,
Thank you, sir.
Thank you so much, Ranjan ji, for giving an insight into this subject. So, yeah. So, I think we have one more presentation.
This is the last one.
Yeah.
Yeah.
Yeah. Can you share your screen, please?
You want to ask some questions? You can take some pictures.
No. He has given a very detailed exploding out.
Okay, can I share my screen?
What is the problem?
Yeah, you want to ask something? Yeah, please.
Yes, I want to ask questions.
Please.
Thank you for that wonderful presentation. However, I just want to get some clarification based on serverless computing in healthcare. I think one of the major drawbacks of serverless computing is security issue. Have you put in place the security measure of serverless computing before applying it to healthcare?
Yes, sir. That is one of the major concern in case of serverless computing, because you don't know where your code is running, in which server your code is running. That is one of the serverless computing is one of the major challenging tasks to protect your data. But for that also some other provisions are there that is provided by different vendors like AWS. They're providing AWS Cognito, and some other modules are also there which are who are providing the security services to protect your data. But yes, definitely that is a major concern in case of serverless computing as compared to other deployment model. Yes.
Okay, sir. Thank you, sir.
Yes.
Okay, thank you. Yeah. So,
thank you.
Yeah, you can continue with this presentation.
Okay. Can I start sharing my screen?
You want to ask? Yeah, you can share your screen. Moses, you can share your screen.
It is not clear. Yes.
Another.
Is it on?
Yeah, it's perfectly fine.
Okay, good. Good morning, everybody.
Good morning.
Okay, I'm going to start my presentation. I'm talking about securing digital transaction using a tree-level authentication system. When we talk about in our world today, authentication system is used to secure valuable things, and every one of us knows that security is very, very important. Most of our valuable data or valuable information or accounts need to be secure. The method of ascertaining users who seek access to a device, system, or network is referred to as authentication. Throughout history, most of the implemented authentication systems have been hacked through, and they have become vulnerable to hackers and fraudsters. So a stronger authentication system is actually needed in our society today to strongly secure what is valuable to people. According to research, people use common password and refuse to use complex password because they believe they will forget them, which makes password they use very weak and vulnerable for unauthorized user to break into. Now, there are four types of factors that can be utilized to verify that an internet customer is the certified owner of what he or she claims to be. And these are what you know. And majorly what you know could be your password, your PIN, and your security code. And this is majorly where people just stop and then they just use their password and they want to use something that is familiar to them so that they will not forget it. And most of the time, it's something that people can actually get to. Now, the second method people can use is to use what they have. What they have could be like a token, could be like a photo ID or a smart card. Another method people can use to authenticate could be what you have, and that could be basically your genuine a user, like from your palm, your retina, your fingerprint, your voice that people can use to recognize you. And then the last one is where you are. This is the data about the whereabouts of a genuine user. And we can use internet protocol and we can use global positioning system as an example of what we can do. In this research work, we have tried to use a three-level authentication system that will involve the use of CAPTCHA, completely automated public Turing test to test computer and human apart system, and then OTP, one-time password, and then a PIN. Now, this is the three methods we are proposing. This method, we believe, will make it easier for people to authenticate their account, and at the same time, it will increase the security of the user's account by making it more difficult for unauthorized users to gain access to them. Because what the CAPTCHA images that you will see are the images that are familiar to you, images that you are used to, and not just what any other person is used to. Not like when they just get your password, they can just get into your account. And so multi-factor authentication system, which we call MFA, is a type of verification that entails knowing the customer through two or more approaches. Instances include programs produced by the customer's smartphone, CAPTCHA test, fingerprint, and so on and so forth. Multi-factor authentication system actually techniques as tools increase customer assurance by employing extra layers of security, which according to Rosner 2020, it offers an acceptable shield against most account hack. It is not without errors, it has no problem, but it's very, very useful. Kumar et al. In talked about authentication method they use an authentication method, which is one-time password, and then to try to limit the access to their data. And then also we have another research also makes use of smartphone app, whereby user will be able to enter their money and then the receiver information is retrieved using NPS. A picture of the sender will be taken, and after successful verification, a 4-digit PIN will be used to finalize transaction. This scheme's limitation is the user discomfort, whereby you have to take pictures every time before you be able to access your account. Asanet also suggested a model called cardless, in which the card is substituted by fingerprint of the user. And then you have not just the fingerprint, but you have to shuffle keyboard method, keypad, so that you'll be able to pick the one you want and just to distract unauthorized user. But each time a user finger is detected, a different layout is displayed. The method is very cumbersome for users and wastes a lot of time. So we are looking at another method that can be very effective. And this is the methodology of what we are looking at. We found out that we look at the figure to show the step-by-step process of what we want to do here. We are proposing 3 methods of authentication for a user, but very simple one. The first one is a password that the user will use to enter the account. And after that, we will check the validity of that one. If it's straight through, then we have to enter the one-time password code that will be sent to the user. And if that one scales through as well, then we'll now use the last one. The last one will be the images that have been predetermined by the user, which is basically known to him alone. And there are 3 images that is very, very familiar to him. So the images will, out of about several images that will be allocated, the user must be able to pick the 3 images that relate to him. And that will also, once that one is checked, then we'll be able to allow the person to be able to have access to his account or to whatever he wants to do on the system. But if any of this fails, then the account is not allowed for the user to come in. So this will basically will prevent unauthorized user to gain access to whatever we are doing. And then at the point of registration, because often before you can use the system, you have to register and become a member. And some of the information we'll need will have been captured at that level. And so once you capture that information, it is easy for us to be able to detect unauthorized user. Even if they get 1 or 2 of the method, it's not easy for them to get the 3rd one. So based on that, we'll look at the implementation. We'll look at the implementation of this system. We'll have a login page where customers will come in on the website, whereby they will enter their information. And after that, they will do what we call the OTP. They are either through their email or their phone, whereby they will get the OTP that they will send to them. And they will be the only one that will receive it, and then they will be able to get it, able to log into the system. And then after this has been done, then they will pick the images available for them from this system. We have 8 possible images that will be shown to them, and they are allowed to only pick 3, which is related to them based on what they have selected for us. So if they miss it, then they will not be able to have access to the system. So based on the implementation, and then we'll look at the process. The process of registration starts with registration, where user must register with the system and then get authenticated before he can request a service. The first level of registration is the PIN, and then followed by the OTP and then the captcha. The experimental results of these 3 level registration are found to be that we found that it's a bit slower in the registration process, but however, it is found to be more reliable when we compare it to a single registration system. And the time complexity of the result for using a single method is faster than using all the 3 methods. That's one of the things that we discovered. But we found that the sending of the OTP was the major cause of this slowness, because the OTP was discovered to take some time before it gets to the phone or to the email of the user. And this is because of the network in some of the cases. So with this, we're able to get the 3-level authentication to be working, and which is a very good one, and to prevent unauthorized user from accessing the system of the system. Then securing an e-banking transaction account with a 3-level authentication system was successful implemented. The system was able to perform its major function of securing a user account from unauthorized user using the PIN, OTP, and captcha authentication. The 3-level authentication makes it difficult for hackers to attack the system and steal valuable data from customers. This study should be adopted by various organizations to use in securing an individual's account, be it an online account or a computer office offline account. The method of authentication could be developed, which is our future work, to accommodate more options in the future. In our future research work, we intend to add biometric options to enhance the security of files on the internet. That's our references. Thanks for listening. I'll be available for questioning. Thank you.
Processing is not there.
Hello.
Okay, thank you. Any queries? Any queries or any comment?
She over this thing. We have some pictures.
Oh, yeah.
I can't hear you.
Open some picture.
Please on your camera as well, so we can also see your figures, your face.
Okay, sorry.
Okay, because we can see your face and we may have a picture all together and we will send as well. Please on your camera. Yes, VB Singh, you are looking is very handsome.
Sorry, my camera is not working. I don't know what happened to my system. It's not displaying camera here.
Please.
Okay, I'm on.
Come on. Who are not coming? Let us see. Yes.
Hello.
Sushil? Sushil, are you present here?
Wait. I want to include a model from Italy. And 4, 3, 5, 2, 1, cheese.
Sushil?
Come on, this side. Take one more. Set one more. Now, please on your cam, right? Please. Don't go. Light is changed.
So you can share your screen, Sushil, you want to present? Briefly.
Any question, Professor Singh?
Yeah.
Sushil? Two sections. There is nobody who can recognize you at present. Because all those attendants are sent immediately after the end of the session. So it is not coming out in another way. Yeah, you can. Come.
Okay.
And you will come on this side. Okay. Come through. And you are also coming here. Yeah. 5, 4, 3, 1. Cheese. Okay. So all the authors are there, right, in the back? How many authors are there? Yes, everybody is present. VB Singh is also there.
Yeah.
Also, there are several. Good.
Okay.
So, thank you so much, Professor Singh.
Thank you so much for a kind of get together of all the researchers working in the area of software quality.
Okay, Ranjan, thank you so much. Adini,
Yes, sir.
Abiuddin, Moses.
Thank you.
Thank you, sir.
Thank you,
And
sir.
Sushil as well. Where is my dear
Sushil?
Joseph? Where is the Joseph?
Joseph quickly went to the
He
toilet.
left now. He went to use the restroom.
He missed. Yeah, na. There's an opportunity to have a picture with the two models from the two big countries, right? From Italy
Okay.
Okay, the section is closed.
Closed, yes.
Closed. Thank you so much. Bye.
Bye. Thank you.
Thank you, Professor Mishra. Thank you.
Bye.
Bye.